Is it my screen is visible to all of you?
Yes.
Okay. So just to talk about the basic terms before we are going to learn about machine learning. Okay. So just to have a small example, what is mean by data set? Okay, data set is a collection of data which is stored on the particular file. Okay, so data set may be a database. So data set may be a list of information. Data set may be a Excel file. Data set may be a some other file format. So data set is an any collection of data. For example, just have a small example for employee data set, which consists of employee ID, employee name, employees basic salary, their job details, company details, address, everything. So collection of employees which is stored on, in the format of any format, either the database format, otherwise Excel file, otherwise comma separated value files, any HTML files, any form of collection of data is called it for the data set. Okay, so this is a one small example for collection of data in the name of the arrays concepts. Okay, talk about the data types of the data set. Okay, for example, employee ID in just a SQL Server point of view, employee ID is an integer data type. Employee name is a varchar data types. Employee is a salary is a decimal data type. So, what kind of data which is stored on the data set, that is called it for data types. Okay, so generally in machine learning world, the data types is classified into numerical, categorical, and then ordinal. So talk about the numerical. So datas are the numbers means, for example, ID integers numbers, decimals salaries numbers. So numerical datas are the numbers can be split into two numerical. So one is a discrete data, another one is a continuous data. So discrete data means, for examples, numbers that are limited to the integers. Example, number of car passing by the particular highway. So continuous data means numbers are of infinite value. There is a no end. So for example, price of the items or the size of the item, it will be varying. There is a no fixed. Okay. So these are the two types of numerical data. Okay. Talk about the categorical data. So categorical data means data are values that cannot be measured by against each other. Okay. So you cannot measure by the particular one. For example, color values and yes or no type of values, you cannot measure. For example, if you go for asking the yes or no question means to the customers means based on their maybe yes or no. So keep it in your mind always. Categorical data are values that cannot be measured by against each other. Okay. Another one is original data. So original data means so like just see data like a categorical data, but can be measured upon against each other. So for example, school grades, maybe A is better than B or B is better than C. Like that you can go means that is a original data. So these are the three variety of data which is used, data types which is used for the machine learning. Okay. So numerical, that is a categorical and then ordinal data. Okay. So talk about the basic operation which is done for the machine learning. Okay. So especially if you go for giving machine learning means your data set. Okay. Once you importing the data set, after importing you must analyze your data set whether data is missing, otherwise data is irrelevant, otherwise noisy of data is available means you must clean the data, that is called it for data pre-processing. So in this data pre-processing, for example, if you any missing value is in that particular column means you can go for finding the mean value, that means average value for the columns and then replacing the average value on the particular missing data. This is a one way. Another way is you remove the missing data and then go for feeding the information to the machine. These are the two way for handling the missing informations. So in that missing information, some technique they can using for a that is a statistical formulas. Okay, that is called it for mean, median, mode, variance, and then standard deviation. These are the formula which is usually used. Okay, so talk about the mean. So mean means average of the value. So median means a midpoint of the value. So mode means the most common value. These are the mean, median, mode operation. Okay, so these are the formula which is used for the mean. We'll understand the formula with using the manual calculation. But if we go for machine learning, usually, mostly, almost 80 to 90 percentage we use the built-in methods only. But you must know about behind the method, what is the reality. Okay. So see to that, I am going to find the mean value. Okay. So here in this mean value, just to see, this is a small example for the values. So these values I am going to finding the mean. So how to find the mean means mean formula is 1 divided by n, sum of I equal to 1 to n xi. That means you are going to sum of each and every value divided by total number of value. This is a formula. So in this example, there are 13 data is available. So go for a sum of 13 data divided by 13. Here it will be generally slash operator which is written the float value. So I want to round the values. So that is a round of 2 decimal precisions. So this system will be written the value is 89.77. This is a way we can go for finding the mean value. So mean value means nothing. Here average of the value is called for mean. Okay. So from mean, we are going to calculate the variance. Okay. So this is a one small example, another example for finding the mean value. So this is a small example for a how to find the mean value with using the NumPy, that is a model. Okay. So this NumPy is, I already told you, NumPy, which is especially used for numerical Python. So numerical Python, especially arrays concept. So in C, C++ and all arrays concept is available, no collection of data for same data types. Similar, Python they can created for the arrays, especially arrays related all the content which is available in the NumPy, numerical Python library. So if I want to use methods from NumPy, that is a package means you must import. Okay. So once import the package, just go for using a particular method. Okay, see to this, this is a mark of the students. There are 6 students. So I want to find the sum value. So sum value means that you can use for the sum function. In SQL Server, we use that aggregate sum function. No, similar, there is arrays, there is a sum function is available. Here, this is a mark is a list of that is a marks of the students. So if I want to find sum value means you can using the sum method. Okay, so suppose if I want to find the total number of items, total number of marks in that particular list means you can using the len function. This is a normal function. Okay, so I want to find manually for mean value means sum value divided by length of the mark means you can able to find the mean value. So here round function which is used to round the floating point. So this is a manual calculation with using the sum function. Okay, suppose if I want to use the mean method means, see the NumPy which having the mean method, I am going to use the mean method to find the mean value. So this is the actual, that is a 6 marks of the students. I am going to find the mean value. The mean function always return the float value. So I go for rounding the value with the 2 decimals here. Okay. So if you want to round, you can go for round. Otherwise, no need to round. Okay. So similar, this is a one salary, 4 employee salary. I'm going to find the employee salary's mean value. So that means average value for all the employees. So this is a way we can finding the mean value. Sometimes this mean value which is used for replacing the empty data in that particular data set. So generally, this is a one pre-processing techniques. So you can directly use the mean method. No worry about. But behind it will be having this kind of calculation only. Okay. So yes, please check for your side. If you have any question, let me know. So this is one more example. Just to see, like a speed of the 13 car. Okay, so I'm going to finding the mean value for the speed of the car. Okay, so just directly I use for the mean value here. If I want to round this value, you can go for using the round function here. Round of x comma 2. Otherwise, x comma 0 means whole value it will be written, integer value. This is the average speed of the 13 cars. Okay, so please try for your side. Here are the types which is available and then further subtopics and that. Okay, so talk about the machine learning. What is mean by machine learning means which is extracting the knowledge from the data. If the data is available means we are going to extract the knowledge or fetching the information or finding something from the data, do the analysis. This is called it for machine learning. This extracting knowledge will be done for machine, not for us. Okay. So generally, machine learning is a subfield for artificial intelligence. Okay, so artificial intelligence is a superset of the machine learning. Okay, so here, how it will be finding such informations means in order to previous experience data. Otherwise, from that, what you are going to giving the data from the data as well, it will be go for finding. Okay, so coming to machine learning in the computer system. Okay, so why we are going to using machine learning concepts vandals means in order to prediction. For example, I am going to predict the future informations, other the past information and all I am having in the data set. From the past information, I am going to predict the futures informations. Otherwise, I am going to take some decisions using the historical data without being explicitly programming. So we can go for using the machine learning concepts. Generally, the machine learnings which we take for a structured as well as a semi-structured data. Structured data, we know the data sets, for example, databases and all. Sometimes they may be take for the semi-structured as well. So after social media, that is not everything is unstructured data. So for example, they can post for video, they can post for text messages, they can share the numbers, the messages, they can share that like multimedia images and all. Okay, so generally it will be go for a generate accurate results or give predictions based on the data only. That is a usage for machine learnings in the computer system. Okay, so this is one small example how a human becoming intelligence based on the previous experience from childhood onwards only. Okay, that information I feed to machine also like a human. So human have the real intelligence power, machine have that artificial intelligence. Okay, just to talk about the types of machine learning. How it will be go and do the analytics means in order to how the human childhood onwards they can store their information to brain. No, similar. I feed the informations to machine. After feeding, the machine will be go for detecting everything with using the information which is stored under their memory. Okay. So talk about that is a types of that is a machine learning. There are three types which is available: supervised, unsupervised, reinforcement. So talk about supervised machine learning. So supervised machine learning is a one type of machine learning which is a generally machines are trained using well labeled trained data. So on the basis of that data, machine predict the output. Okay. See to that, these are the labels data. Okay. For example, I feed all the, that is a shapes information to machine and then inform if the shape having this much side means the shape is this name. Like that, I feed all the labeled data to train my machine. Once the train is, the machine is trained, I can go for finding the a prediction with giving the some sample inputs. See, this is a testing data, just a square picture and then a triangle picture I given to machine. Machine will be just to predict the information based on the previous trained data. Okay, so it will be identify this shape is a square, this shape is a triangle like this. This is a way we can train for my machine means that is used for supervised machine learning. Supervised machine learnings are trained using well-labeled training data. Okay. So coming to unsupervised machine learning, here we cannot train our machine for labeled data. So then how it will be detecting the information means based on the input you given. Okay, for example, this approach is another way. We have no target values, so we can only input variables at the hand. The algorithm learn by itself and discover it a impressive structure in the data. So from the input, it go for a finding. So this is a way we can go for using the unsupervised machine learning. Okay. So reinforcement machine learning is another approach. So this machine learnings are trained make a series of decisions based on the rewards and feedback they received from their actions. Okay. So if we go for a do for reinforcement means you can use for example based on that feedbacks given from that user you can go for take the decisions. Okay, so this will be achieved for the complex as well as based on a uncertainty situation only we are going to do for the reinforcement. So in this training we'll try focus for supervised and then unsupervised machine learning. Okay, so just talk about these are the three classification for the machine learning. Okay. So whenever you are going to do any machine learning or data science programs means you must pre-processing your data. Okay. So data means information, collection of informations, maybe numbers, maybe images, maybe alphanumerics format. Okay. So whatever data you given to the that is machines to feed before that given to the machine, the data should be proper. Okay, so that is called it for data pre-processing. What is mean by data pre-processing means a process of preparing the raw data and making it suitable for machine learning models. It is the first and crucial steps while creating machine learning models. Okay. So before I am given to my data, the data should be a pre-process. Okay. So ensure data is clean. Data is without having machine data, without having any relevant informations. This is called it for data pre-processing. So they can have to apply for the steps for pre-processing your data. So first step is getting the data set. So you getting the data set in the form of either you can create your own data set, otherwise you downloaded from any data set repository, that is called it for getting data. After getting data, you can import what are the libraries which is used for doing the that is a feature predictions or doing machine learning types, any types. Okay. So after that, importing the data set. Okay. So once you getting the data set, you must import the data set. Then only the data will be loaded to that particular one. Okay. So after that, you can finding the missing data. If any missing data or irrelevant data is available, means you finding. So finding and then overcome the particular one. Okay. So finally, you can not finally, before finally, you must encoding the categorical data. For example, just to see employee database. Okay, so employee ID numbers, employee name varchar, employee salaries numbers. You cannot have a different, see numbers, decimals, and then strings. So you cannot have a give the information like that. You must either you must convert all is a string, either you must convert all is a decimals. So that concept is called for encoding the categorical data. Okay, so after that, splitting data into training and then testing set. This is a purely about the supervised machine learning. Okay, so I define my whole data to one is a training set, another one is a testing set. Okay, so after that, you can go for a do the feature prediction. That is a feature scaling. So these are the 7 steps for pre-processing your data. We'll see one by one. Okay. So first one is a getting data. Getting data means you can download data set from any repository. Otherwise, you can create your own data. Otherwise, if you have a data in the form of any files means it will be taken as a data set. Okay. So usually machine learning, they can go for CSV file. CSV means comma separated value files, but you can able to give any form of files as well. Okay. So download the, otherwise you can make a comma separated value files. After comma separated value files, you can go with the, do the further one. Okay. So let me, okay, 1 minute. Let me share the rest of the part. 1 minute. Data is missing, no? Okay, 1 minute, let me check. I think this. Oh, yeah. From this one. Mhm. Okay, copy. Please refresh the Colab notebook. Please refresh your Colab notebook. You can able to see the rest of the concept as well.
Fishing.
Okay. So yes, can you able to refresh your Colab notebook? Can you able
Yeah.
to see the rest? Okay, fine.
Yeah, I can see a lot of that random number.
Yes. Miss Rajayash, can you able to see?
Yes.
Okay, fine. Okay, let me have a small example for how data distribution will be there. Okay, see to that, I am going to creating this 250 floating numbers. So this is a method which is used here. That is a uniform method. So this method which is used to create the that is numbers. Okay, so especially decimal numbers particular range. Okay, so from 0.0 to 5.0. So this is a mean value, this is a standard deviation value. From this particular values, I am going to generate 250 random numbers. So that's why I am going to using here. So if you run the program, so you can able to see the random number. See the first number 1.96. Okay, the first number is, for example, 8.9 like this. Okay. Suppose if I run once again, so it will be each and every times it will be given for a different random numbers to me. Okay. So here this random method which is used to generate the random numbers. Especially I am going to using the uniform method. So here this is your mean value, standard deviation value. I am going to generate 250 float numbers. Okay, so that is like a one array I am going to create. Okay, so if you want a return types C means you can see the return types as well as C. If you go down, so total number of random number is 250. So from that particular range, it will be written the 250 like this numbers. So this is a distribution. For example, I'm going to generate this numbers. That's why I'm demonstrate this one. This is a one more example from 10 to 20. That is 1,000 random numbers which is display here. So this is a way we can generate our own data set. This is one smaller example. Okay, so from this, I am going to converting this distribution numbers to histogram graph. So that's why I am going to using the PLT, that is a matplotlib.pyplot library. So here this is a histogram graph I am going to just display. So X as well as based on the 5. Okay. So 5 categories I am going to convert this histogram graph. Category 0 to 1, 1 to 2, 2 to 3, and then 3 to 4, 4 to 5 like this. So see the output. You can able to see the from the random numbers, the categories of that is a histogram graph is there for 5 different category. Okay. Similar, for example, this is a one more example. That is 1,000, no? That is from 10 to 20 thousands. That is numbers, distribution numbers we created, no? So this is another histogram graph. So this is one more histogram graph for 10,000. Okay. So this is a one more graph for using the normal method. So this normal method here, a mean value, median value. So sorry, mean and then standard deviation. So the mean value is 5.0. So most of the value which is closest to mean. So see the bell graph here. So like a histogram, that is 100, that is bars we are going to having, that's a categorical. So from this, the graph is like this. So here, this 5, this is center one is, no, this is a mean value. So the rest of the, that is a distribution value is which is closest to mean value. Just a distribution of the, how the categorical shapes which is there in this bell graph. Okay. Okay, so as usual, just a basic intro about the plotting or graph conversion. This example, especially scatter graph, just have a small example. This is the age of the car, the tin car. This is a speed of the car. Okay, so from this age as well as speed, we are going to converting the data to visualization. See the example here. Okay, sorry. Here there is a capital letter X. From this, see the output. So here also capital letter X. So this is a scatter graph as well as a bar graph of the particular 13 cars. From the graph itself, you can able to find this is a highest speeding car if it is age is a minimum. If it is age is a 4 means see, this is the least one. So these are the middle level. Just visualization only. If you want to format, you can go for using the titles, X label, Y labels, names and that. So this is another one graph for a student mark information using line graph as well as a pie bar graph and then a pie chart, scatter graph, everything. You can able to do multiple graph in a same data as well. This is one small example. So this is another example. Random distributions of the numbers. Based on the numbers, you can go for converting the visualizations. So scatter graph. Okay. Now, talk about the supervised machine learning. Okay. 1 minute. I want to take one picture from that another notes. 1 minute. Okay. Linear regressions. Okay, never mind. Okay. So talk about okay, 1 minute. So just to have a small example, supervised machine learning. There are two types is there, regression and then classifications. Okay. Unsupervised machine learning, that is a clustering and then that is a dimensionality deductions and then here reinforcement which is purely about these concepts. Okay. Let's talk about the regression topic. Okay, 1 minute. Let me, I will explain this. This tutorial, okay, little complicated. 1 minute. Okay, let me explain from our exercise itself. Okay. Okay, so talk about the regressions. What is mean by regressions means, for example, I am going to made from the relationship between the variable only. Okay, so for example, Just to have a small example, this is my data points. From the data points, what suppose I am going to do means, I am going to draw the one slope between the particular points. Mostly the slope which is most closest to the all the datas. Some datas only it will be far away, but see most of the datas which is closest to the particular line. So from this line, I'm going to finding the future predictions. So see to that regression, there are a variety of regression is there. Linear regression, polynomial regressions. So we'll see one by one. So here, finding the terms regression is used to find the relationship between the variable. Okay, so we can go for using the why we go for with using the relationship means in order to find the predict the outcome of the future events only. So this is a one small example for how the linear regression is occur. Linear regression, that is a relationship between the data points to draw a straight line through the all them. Okay, so for a predict the future value only. See how it will be do means just see one small example and down. See, this is one small example. For example, I want to find the that is a 10. If I age of the car is 10 means how much miles it will be given. Okay, so it will be finding like this. This is a one straight line which is closest to all the variable. From this, if I want to find a 10 age means it will be like this. It will be go for x-axis and then y-axis intersection for the particular line. This is a future predictions. Suppose it will be 16. Suppose if it will be 18, 19 means here the you can extend the line. If I want to finding any values means you can extending the line to find the particular predictions from the data set. Okay, so this is a behind scenario for the regressions. Okay, so just will have a small example, understanding, clear understanding for a line by that is a each and every exercises. Okay, so just to see this exercise, this is a for example 13 cars age. This is a mileage of the particular cars. Okay, from this we are going to convert it to scatter graph. See, the scatter graph is like this. Okay, so similar, for example, how we are going to finding the linear regressions. We can using for the built-in function only. If you use the built-in function, the function will be return the value to you. So see to this example, this is one small example for a linear regressions. So here we are going to using the matplotlib lib.pyplot, especially used for visualization. So SciPy, from the SciPy, I am going to using the states, libraries, or models, or package. So from this states, I am going to using the linear regression, that is a method. Okay. So this example, when I use that linear regression, this linear regression which is happened for the relationship between the x as well as a y variable. So x is a, that is a independent variable. So here it will be represent capital letter. Small letter y is defined for the dependent variable. So based on the age of the car, the mileage will be there. If the age is a little more, the mileage will be slower. Okay. So that is a scenario. Okay. So here I am going to finding the linear regression. Linear regression when I call means it will be retain some values. The value is called it for slope, intercept, R, and then P, and then standard error. Okay, so just to see the slope plot. Okay, so for example, slope of the regression lines, which is a new lines we are going to draw, no? That is a slope. Okay, intercept float means, for example, if you want to finding any new means new lines means which is having the intercept. Okay, so and then R value, that is a correlations coefficient value. P value means there is a hypothesis test value. And then standard errors means, for example, estimated slope, under the assumption of the that is a residual normality. Okay, so next one is a intercept standard float, which is assumption of the residual normality. Okay, so these are the value which is written for the regressions. So from this value we are going to do for the predictions as well. Okay, so here I am going to printing the that is all the that is a linear regression value. So the linear regression value for a value with slope, intercept, and then R value, P value, everything will be there with using the calculation. Behind they can having the formula to calculate. Okay, so next I am going to see, this is a one function which I am going to write here. This function, especially for example, I am going to draw the one line based on the relation of the particular variable. So the dot is mentioned for my data set. So here the line which is drawn, no, so I am going to finding the that is a new that is a data value for a which is closest to all the data variables, previous variable. So after finding the that is a new that is a intercept value, I am going to draw the line over there. Okay, so that's why I am going to using this function. This function especially used to return the new values, new x values. Okay, so from this x and then y value, I am going to draw the line over there. Okay, so for that only I am going to using this function. This function represent y-axis and the corresponding x value will be placed. Okay, so define my function x, return slope times x plus intercept value, which is a return from the linear regressions. So finally, my model is equal to list of map of my function comma x. Okay, so this is the actual that is a new predicted that is a the line which is drawn, no, that value. Okay, after that just you can go for the scatter graph for x and then y value and then x and then so next this plot which is used for x as well as a my model. My model is a new y value which is written from the linear regressions. So which is closest to the previous datas. Okay. So finally display the value. So if you run the program, you can get the result is like this. Basically, so mostly all the datas will be closest to this particular line. So some data which is away. So there is also which is have the relations. Okay. So similar, this is another example. Just having another example for our new data sets. Okay. So suppose if I want to find the 10 years old car mileage means. In this example, see, there is a no 10 years age old car is there. Okay. So I want to find. Okay. So just I go for giving the my functions with the datas. So if a data is 10 years old means how we are going to find it. So 10 years old means it will be like this. That is interception for the 10 as well as their related y. So this y is the actual finding speed of the particular car. So 10 is the x-axis. Okay. Just I pass the x-axis value from this return function. It will be returned the new y values. The new y value is my actual finding. Okay. If you run the program, so you can able to return the value is 85.59 like this. See, this is interception. So it will be closest to 86. So this is also one more example. Just for example, go for finding the salary for 19 years of experience in the employee as well as 37 years of experience in this employee. So you can find the future predictions. If the employee having 19 years, this much salary, which is predicted from the previous data set. So if it is 37 years means how much salary the employee will be get. So this is another example with using the linear regressions. See the data points which almost all closest to the new slope. So all is see the red color dot no, which is a new y value based on the x as well as a new y value, which is a draw over the particular slope. So this is a one more example. So generally, the R value which is written for the linear regressions, no, there is a correlation value. So if it is R value is closest to 1 means predictions will be more accurate. If the R value is not closest to 1 means predictions is not that much accurate. See this example 0.9, almost 1 value. So the prediction is most accurate. Suppose see the bad fitting, see the R value, is 0.01. So this is not a perfect fitting for all the relation of the data. See the example itself, all the points will be away, few only it will be closest to. This is a bad fitting. Okay. So please try for your side. So some data set which is not suitable for linear. See, this data is not suitable for linear regression. So we'll go for the another regression, that is a polynomial regressions. Based on the data, the line will be bend as well as a draw for the future predictions. These are the different variety of polynomials is available. Similar for linear regression, we can go for using the polynomial method to finding the future predictions. See how it will be finding. If I am finding the 16 years old information means it will be having like this. Linear regression, straight line, polynomial regressions, multiple lines on the data set based on the data. So sometimes it is also not a fitting. So we'll go with the multiple regressions. So this is called it for regressions. Linear, multiple, and then polynomial. Okay, so please try for a run the linear regression programs. Once you done, let me know and then we'll explain for the polynomial regressions.
Okay, sure.
Yeah, please. Multiple. Linear regression, we can draw only one line on the particular relationship between the particular data sets, data points. But polynomials means based on the data set, I go for draw the multiple lines over there. That is called it for polynomial, many lines. So this polynomial regressions, because sometimes, yes, I already told you, know, the correlation value, that is R value, R square value, which is not closest to 1. That means that is a bad fitting for the data points. If you go for bad fitting, the future values, which is not accurate. So in order to avoid that one, there is a one more regressions topic is that is a polynomial. So this polynomial which is used for we can draw the lines, multiple lines over the data points. Okay. So based on the relationship, we are going to draw the line through the data points. So this is one small example. Here, based on the data points, we are going to draw the lines. Okay, so polynomial lines. This is one small example. See, x value, y value. We are going to draw the visualization using the scatter graph. So using the polynomial, see, this is a polynomial methods. For example, let me go for using this polynomial method which is there in the NumPy. Okay. So numerical Python library. So from the numerical Python library, I go for finding the polynomials. Polynomial means fitting to the particular x value and then y value. So this 3 which is representation for number of that particular lines. Okay. So based on this information, data points, we are going to draw the that is polynomial lines over the previous data points. Okay, so the lines will be like this. For example, the lines will be 1, 22, hundreds. The line will be displayed. We start at the position 1 and end at the position 22 like this. These are the data points. So line will be starting to 1 to 22. Based on the particular data points, the line will be drawn. Okay. So from this, you can go for using the finding the feature predictions. This plot of polynomial model, which is written for the new y value, that is x x and then y value. From the y value, we are going to draw the lines over there. Similar, this is a line space. Okay, so here line space. So if you go for finding the value means see r square value, which is written for 0.94. So there is a perfect fitting. So this is a relationship between that one. Similar, there is a one more example. Speed of the car. We are going to finding the, if it is a car age is like 17 years old means how we are going to finding. So here that is the interception for this x and then y axis. So this is a new finding value, so which is closest to almost 89 like this. So this example, this is a one small image which I added for understanding purpose. Okay. One more example. Speed of 25 years old car, 35 years old car. So how much speed is that like this? So even polynomial also, there is a bad fitting is there. So next we'll go for the multi-regressions. Multi-regressions, we can go with predict the future values and all. We can go for using the multiple regressions. So this is a one small model for the multiple regressions. So here, how we are going to predict the values. This is one small example for the car CSV file. Okay, let me, okay, 1 minute. I will share the car CSV file as well. Okay, 1 minute. Now one smaller car CSV file, that is a data set. Okay, so just download the data set and then upload it to Colab notebook. So this car CSV file, which consists of like a car's weight as well as a car carbon dioxide emissions details. Okay, see 32 cars details is available: car name, model, volume, weight, and then carbon dioxide emissions. Okay, so based on the volume and then weight of the car, the carbon dioxide emissions will be either less or more. Okay, so we are going to finding let me check. See, these are the variety of cars and then model, volume, weight, carbon dioxide emissions. Almost 36 entries is there. Okay, from this, we are going to finding carbon dioxide emissions for the car based on the weight as well as a volume. Okay. So suppose if it is a go for predict the value is a weight is 2300 kg and then volume is a 1300 centimeter cube means how we are going to finding the that is a carbon dioxide emissions, which is used for predicted the values from the linear regressions. These are one small examples for a multiple linear regressions. You run the programs, you can able to display the result is like this 107.2087. So this is one small example for how we are going to do the analysis with the data set. So here data set which is having the CSV file. So I go for using the pandas and then sklearn, that is a linear model, especially for a multiple linear regression. So sklearn is a parent library for linear model libraries. So from sklearn, I am importing the linear model. So pandas, which is used to convert your data set to two-dimensional array, that is a data frame. So for that only I use the pandas.read CSV file. Reading the CSV file, convert the data to two-dimensional. So from the two-dimensional, I go for taking only two independent variable, weight as well as a volume. Based on the weight volume, the carbon dioxide is there. So dependent value is carbon dioxide emissions. Okay. So from these values, I am going to finding the regression. There is especially multiple regression, and then fitting the X value and then Y value to find the future predictions. Okay. So when I go for predict the carbon dioxide emissions based on the predicted, that is weight as well as a volume, just I pass the value here. From this predicted method, this is a built-in method, which is in the regressions model, regression library. Okay. So here from this, it will be do the calculation and then return the value to you. So this is a value which is written for the one. Similar, there is a one more relationship for the, that is a multiple regressions based on the weight volume. It will be go for finding the predictions. So this is the explanation how that weight volume will be taken and then how to calculate the emissions. Per kg, this much emission though. So that much kg, how much emission, like that we can have the explanation. This is one more example, similar. Okay, so if it is a weight as well as a volume is like this, means how we are going to giving the values. So the value will be little more. These are explanations. Similar, one more example, same multiple one with using a different data. So how it will be calculate the predictions with using the scale. This is one more example for a training as well as a testing set. So for that, we generate the random numbers, 100 numbers. From that numbers, we can go for using a predictions. So from the number, I go for splitting 80% of numbers to, that is a 0 to 80, 0 to 79. training set and then testing. So training X value and then training Y value and then training X, testing X and then testing Y. Okay. So how we are going to splitting the training data as well as the testing data. See, from that is original data, that is for example, 100 data is available, means I split my data. 80% is a training set, 20% is a testing. So this is a small example. From 0 to 79 in that X train set, and then rest 80, that is a Y train, and then from 20 to rest, that is a testing, and then from 80 to, that is a Y testing. So from X data, Y data. So from here, we are going to draw the graphs X train as well as a Y train. So this is an example. So and then show method, which is display the result. So this is a testing set, 20% of data. So that is a visualization. So this is a one example for from the training set as well as a testing data. Go for do the polynomial regressions. Similar testing data, polynomial regression, and then finding the future value. So see, it will be R square almost 0.7. So it will be acceptable. Okay, the relations. If it is a not that much close, that is a bad fitting, you go for some other regression. This is one more example for the another polynomial examples. Okay, so please try for your side. So everything behind there is an algorithm which is apply for the methods only. Just we are going to add, use the algorithm. So if you know what are the value which is written on the algorithm, why you use the algorithm is that is most enough.